Okay, so now for the greatest common factor, our definition is the greatest common factor, or GCF, of a set of expressions is the largest expression that is a factor of all the expressions in the set. Blah. So that might seem a little confusing, but of course we'll look at examples to parse out what this means. So suppose we have this set of three numbers, 30, 6, and 48. The greatest common factor is 6 because 6 is a factor of each of the numbers, each of the three numbers of the set, and no larger number is a factor of each number in the set, right? So 6 goes into 30, 30 equals 6 times 5, 6 equals 6 times 1, 48 equals 6 times 8. So 6 is a factor of all three. Now you're not going to have a larger factor because one of the numbers is actually 6. So in this case, it's fairly obvious that there isn't a larger common factor. We don't count things like a half here. We're just counting integers. So 3 is also a common factor of 36 and 48. But 3 is less than 6, so 3 is not the greatest common factor. It's not the greatest such number. Okay, so the greatest common factor would be 6. 2 is also a common factor, and 1 is a common factor. And of course, -1, -2, -3, -6 are all factors. But 6 is the greatest one. So this is an example with a polynomial. We have 2x cubed minus 8x squared plus 4x. 2 is a factor of all three terms, okay, as is x. And so the greatest common factor has to include the factors 2 and x. And then you look, is there anything else that they have in common? And, well, if you look at the coefficients, the greatest common factor of the coefficients is 2, and the greatest common factor of the variable parts is x, and so that's it. So it's just going to be 2x. So there's no additional factors common to all three terms. We're not counting 1, and the reason is because 2 is bigger than 1 already.